together and we're going to sketch rational functions. Still fun. So let's take a look at our first example. So in your notes packet, you guys can see there's some steps numbered 1 through 8, and those are just some guidelines of things that you might want to do first. But you might find that it's easier to do one thing first than another, but that would be my recommendation, steps 1 through 8. So here is f of x. We want to sketch a graph of this. Now, before we do anything else, we do want to make sure that we make this look like a rational function. So if I multiply 2 by x squared over x squared, now I can rewrite this as 2x squared minus 3 all over x squared. So this looks a bit better. Now, step 1 in your notes says factor. Factor both the numerator and the denominator. And in this instance here, there's really not much to factor, so let's move on to step 2. Step 2 says check for holes. Although we didn't have any factors that match in both the numerator and denominator, so no holes. And in fact, we can start kind of listing things down here where we're asked to state the following. So we'll say none, no holes. Next thing, we want to find our x and y intercepts. So for our x-intercepts, remember we want to set y equal to 0, and really it's setting our numerator equal to 0. We solve, right, so add 3 to both sides and divide by 2, so we should get x equals plus or minus square root of 3/2. If you want to go ahead and rationalize that denominator, you can. You do not have to. We've talked about that before. So I have two x-intercepts. I have the square root of 3/2, comma 0, and negative square root of 3/2, comma 0. I put that and symbol in there just because sometimes when you don't, students will think that I'm making this like an interval, but remember they're ordered pairs. For my y-intercept, we're plugging in 0 for x. So if I do that here, notice that, we get that as being undefined, which actually kind of brings us to needing to identify our domain. So let's do that right now. Our domain, what is the number that would make this undefined? 0. So our domain is -infinity to 0, union 0 to infinity, which is why we don't have a y-intercept. Okay, now let's start talking about our asymptotes here. So for our asymptotes, remember our vertical asymptotes, which I think is easier to find first, we have to look at where the denominator equals 0. That would be at x equals 0. Where does our, now we have to, for our horizontal asymptotes, we want to look at the degree of the numerator compared to the degree of the denominator. And both of them are the same. So remember, that's that case where the horizontal asymptote is equal to the quotient of the leading coefficients. So that's going to be y equals 2 over 1, which is y equals 2. Now, we've done everything we really need to here. So what we can do is we can start graphing the things that we have identified. So I'm going to start by graphing my asymptotes. I'm going to make a dashed line, so vertical at 0. I have a horizontal one at y equals 2. I'm going to go ahead and plot my x-intercepts here. Now, the square root of 3 over 2 is some decimal that's just over 1, so I'm just going to approximate here. Then I have its symmetric point for the negative square root of 3 over 2. And based off of that, I can kind of fill in my curve here. I have an idea of what this is going to look like. If you aren't exactly positive, you can always plug in points, right? Table of values and try to get some more until you can kind of vision what the that curve looks like. And there's my graph. Next example, which doesn't tell you what the problem is, but hopefully it does in your notes. We have h of x. What I'd like you to do on your own is I would like you to identify all of the, characteristics that are listed on the left-hand side here. So go ahead, pause me, and do that on your own. And then together we'll go ahead and graph this guy. All right, so go ahead and put me on pause. All right, if you're ready to check how you did, let's move on. So you can notice in my first step, just as it says in the guidelines above, I started by factoring, okay, which allowed me to see right away I have an x plus 4 factor in both the numerator and denominator. So already I'm kind of anticipating here, okay, I'm going to have a whole. So domain, finding where our denominator is undefined, that's infinity to negative 4, union negative 4 to 3, union 3 to infinity. Horizontal asymptote, I'm looking at the degree of the numerator and denominator. They are the same. Quotient of their coefficients. Vertical asymptote at x equals 3. I don't have a vertical at x equals negative 4 because instead I have a hole at negative 4. And a reminder, how do we find the y value of that hole? Well, you got to plug in negative 4 into what's left of your function once you cancel out the factors of the hole. Keep going. X-intercept 4, 0, y-intercept 0, 4/3. Okay, so now comes the part of graphing it. Remember, we want to start by, let's put our asymptotes on there. It's just easier to have those as a guideline. X equals 3. Okay, now where I have a hole at negative 4, 8/7, I'm going to actually put a hole there. So I have negative 4, 8/7, so I'm going to put a hole right about there. Okay, I have an x-intercept at 4, 0. I have a y-intercept at 4/3. Something like that. Okay, now I can kind of envision what this is going to look like here. So just connect. Again, if you weren't sure, like, oh, should the curve be in, which quadrant here, go ahead and start making a table of values till you have a better idea. Okay, so there's our second graph. Oops. All right. Last example here, which again, I don't have it on here, but you have r of x, r for Reptown. So r of x is x squared minus 4 over x plus 2. Notice that this one, I want you guys to be careful here, but we are going to have you guys try identifying all of these on your own once again, just like you did last time, and also try to graph it as well. Okay, so go ahead, put me on pause, and then we'll check how you did. All right, let's see how you did. So I started by factoring r of x, and I'm already noticing I have a hole at x equals negative 2. So my domain, I have negative infinity to negative 2, union negative 2 to infinity. No horizontal asymptote, no vertical asymptote, because instead that's going to be a hole. I have my hole at negative 2, negative 4, x-intercept at 2, 0, and y-intercept at 0, negative 2. So when I'm looking at the graph of this, it does end up looking like a line if you look at your reduced rational here, because of the holes factoring out, or the factors of the hole canceling out, it does look like an equation of a line. Just know here that if you do graph this in your graphing calculator, you might not be able to see that hole in that calculator. So calculators are awesome, but not always 100% smart. But yeah, if you got that right, then you should be good to go. All right, so just a conclusion here. So domain, we set the the denominator of the original function equal to 0 and solve for x, and take that out of our domain of the real numbers. Vertical asymptote set denominator equal to 0 of the reduced function, I should mention. Whole, if something of the original function cancels, that leads to the x value of the whole. Plug that into the reduced function to obtain the y value. Horizontal asymptote, we have those three cases that we are going to look at the degree of the numerator versus denominator. X-intercept, you set the numerator equal to 0. Y-intercept, you plug in 0 for x. All right, thanks you guys for listening. We'll see you in class.